Hello, everyone. Thank you for joining us today. My name is Arnaud. I am a meteorologist at PredictWind, and I've been with the company for about 10 years. So I'm very happy to be here today to do this presentation about El Niño. So at the moment in the news, El Niño is a hot topic. A lot of people are talking about it. This is why at PredictWind, we decided to do this webinar about El Niño to really explain simply what is El Niño from a scientific point of view, and also to have a special focus on the impact of El Niño for sailors. Here is a presentation I'm going to do for the next 45 minutes. What is the outline? So in part one, we're going to look at what is El Niño. So to really break it down and know what we're talking about. In part two, we're going to look at, is 2026 going to be a strong El Niño year? In the media, they talk about super El Niño. In part three, we're going to look at the impact of El Niño on the global weather. And finally, part four, which is, in my opinion, the most interesting part. And this is why I kept it to the end. So hopefully you stay with us until the end, which is the impact of El Niño for sailors. We are going to look at the Pacific Ocean. We are going to look at what are you going to expect if you do a passage in the Atlantic. And we will finish with the Mediterranean Sea. So now let's get started. What is El Niño? So let's start with a simple definition. One sentence. El Niño is when the Pacific Ocean becomes warmer than usual. And why it's important for sailors? It can change normal wind patterns and create unusual weather conditions at sea. So to explain El Niño, we're going to use the following methodology. First, we're going to look at the general weather over the Pacific Ocean. And this is the equilibrium, sometimes also called neutral phase. Then we're going to look at what happens when the equilibrium changes and El Niño happens. So El Niño in Spanish means the little boy. That's why I'm using this icon. And then we will look at the opposite of El Niño, which is La Niña, which means the little girl. I am going to use those icons in the rest of the presentation. So each time I show a drawing or a weather map, I will put this icon so we know if we are in the equilibrium phase, El Niño or La Niña. So let's start with the equilibrium. So this is a drawing of the Pacific Ocean. So on the right-hand side, we've got Americas, and on the left-hand side, you've got Asia, Australia. So a common pattern are the trade winds. So the trade winds, I like to think about a big fan, which works 24 hours a day, 7 days a week. And those winds blow from east to west in the tropical Pacific, from America to Asia. Those winds are well known to sailors. Let's say if you cross the Panama Canal and get into the Pacific, you will be sailing to Galapagos, French Polynesia, Fiji, New Caledonia, Australia, and so on. So what is the consequence of those trade winds on the Pacific Ocean? The consequence is those trade winds push the warm water at the surface to the west side of the Pacific. A little bit like a hot tub, if you got some wind and some waves, the hot water will go to the other side of the tub. There is a significant difference in water surface temperature between Eastern and Western Pacific, and it can go up to 10 degrees Celsius, which is 50 degrees Fahrenheit. Here is a quick note. We refer to surface temperature as sea surface temperature, which is SST, and this is what I will use for the rest of the presentation. And what happens on the eastern side of the Pacific, we have cold water. And this cold water is actually coming from deep below, from the bottom of the ocean. It's a phenomenon called upwelling. In order to really feel this difference of temperature between Eastern and Western Pacific, let's look at a special place here in Peru. So it's called Chicama. There is a famous wave over there. It's located at 7 degrees south. And as you can see, the foiler is wearing a full wetsuit because the water temperature is much colder. If you are at 7 degrees south on the Western Pacific, it will be regular swimming suit. What is the consequence of this warm pool of water on the atmosphere? On the west side, the air temperature is going to get warmer. And as we all know, warm air rises. And then it creates clouds, rain, and unsettled weather only on this part of the Western Pacific, not on the eastern side. And this creates an air circulation, almost like the sea breeze. So in altitude, you're going to have a westerly wind, then it comes down over Eastern Pacific, and at the surface, you've got easterly wind that reinforces the trade winds. So this is it. This is an important map. This is the equilibrium weather over the Pacific Ocean. So a quick takeaway to remember is you've got the warm water on the left side of the Pacific, and you have the trade winds. So now let's look at what happens when the equilibrium is disrupted and El Niño happens. The first sign of El Niño, which is about to happen, is to have a weakening of the trade winds. I like to think about it as the fan has been turned off. That's why I'm using a little fan. And the consequence on the SST is the following. The warm water is moving to the east side because you've got less warm water being pushed to the west and less upwelling as well. And this changes everything for the air circulation. Now the unsettled weather is centered over the Pacific or Eastern Pacific. Once again, what are the takeaways? When you have an El Niño, you've got weak trade winds and the warm water of the ocean is more central or even Eastern Pacific. So quick recap, we've seen the weather during the equilibrium with a regular fan, regular trade winds. We've seen El Niño with a weak trade wind. And maybe the question you have for me is, what about La Niña? La Niña is actually when the trade winds and when the fan is much stronger. And this changes by pushing the warm water further to the west. As you can see, the equilibrium and La Niña phase are not really different. This is just more or less regular weather on steroids. El Niño is completely different. It's more disruptive. It's changing everything. This is why El Niño is more important, or people pay more attention to El Niño than La Niña. A quick way to remember it is the little boy is more disruptive than the little girl. Scientists refer to this as a El Niño Southern Oscillation because this can be seen as a pendulum. You start with the equilibrium, then you go into an El Niño phase, you go back to the equilibrium, then back to La Niña, and so forth. I want to mention that all those drawings are taken from the UK Met Office, from a YouTube videos. And so if you have time, I suggest you follow this link and watch the video later on. So this ENSO oscillation, as I mentioned before, this is an oscillation going back and forth. So in order to study an oscillation, you need to study two things: the period of the oscillation and also the amplitude, like you will do for any oscillation, for example, a wave. So let's look at the period of the ENSO oscillation. The period is 3 to 5 years, and an El Nino event lasts roughly 1 year, 9 to 18 months. So if I represent this period on this map, it means that I enter El Nino, then it goes to the maximum, then it goes back down, and I will stay there between 9 to 18 months. So I am usually, typically it starts in April, June. So now, June 2026 is the beginning of El Nino. What I want to really stress is El Nino is a long-term oscillation, 3 to 5 years. It's very different to other type of oscillation you may be familiar. For example, you've got the seasonal oscillation, which is 1 year. Another oscillation that will be the topic of another webinar, which is called the MJO, which is only 30 to 60 days period. El Nino is a different beast. It's a long oscillation. So right now, media are talking about it all over the news, but really, it, El Nino is not a short-term thing. El Nino is going to be with us for the next 9 to 18 months, let's say 1 year. Now we want to look at the amplitude. So some events are stronger than others. For example, the last big El Nino was 2015 and 2016. So some events are bigger than the other. This is not like a piano metronome. This is Mother Nature, and some amplitudes will be stronger than others. The maximum amplitude is typically October to February. And so my guess, if I have to do a guess, for this year, it will be the maximum El Nino will be around Christmas time, 2026. And here is a fun fact. Why is it called El Nino? It was called El Nino because of baby Jesus. Okay, the people living in South America, they have their weather impacted by very strong floods because of El Nino for centuries. And they have noticed that it comes usually around Christmas time. So maximum amplitude is typically there. So now that we saw this oscillation, I want to explain how scientists, know that El Nino is coming. How is El Nino measured? How can scientists say that El Nino is coming right now? So they use an index, which is the Oceanic Niño index. And I have put this scary formula. So I'm going to break down this formula. And the goal is understanding how El Nino is scientifically defined, help us get a better understanding of El Nino, and also seeing the limits of the index. So this index is built by SSTs. So you guys know what is SST, sea surface temperature, but here the scientists are using real measurement. Okay, they are looking at temperature from buoys, from ships, satellites. So something to stress, this index is based on real measurement, it's not a forecast. So this is the reality. This is the real deal. But they use a concept in meteorology, which is anomaly. We just don't take the SST by itself. We use the anomaly and we subtract the climatological normal, which is a 30 years average. For example, plus 2 degrees instead of 25 degrees. Then, in order to build a strong index, you need to average it. The first thing is to look at a phase average. So they are looking at a big chunk of the ocean, a region here, which is called Niño 3.4 in the tropical Pacific. And they also do a time average. They are looking at a 3-month average. Okay. This is why they use a sigma. Why all those averages are important is because they make a strong, reliable index. Okay. For example, if you are in the Galapagos and you want to go for a swim at the back of your boat, okay, you may go tomorrow and say, oh, it's pretty cold, but this is not scientifically relevant. You want to have an index looking at a big part of the ocean and also a big average, not just today, for the past 3 months. And the beauty of the index is you have all the complexity, but then you just have one single value. As an example, plus 0.5 degrees Celsius over the past 3 months. So now that we understand the index, there are some tables here. And for example, the neutral phase is when the ONI is between minus 0.4 and 0.4. El Niño is everything positive, big positive, and La Niña is everything negative. What to remember? Two numbers, plus 0.5 degrees. When the ONI reaches this value, El Niño starts. And the second number is plus 2 degrees Celsius. When this happened, we are dealing with a very strong El Niño, or as the media put it, super El Niño. So now, hopefully, the ONI index is clear for everyone. Let's look at this index, for 2010 to 2019. So as you can see, we oscillate between La Niña in blue, the black is the equilibrium, and then we have El Niño. And this is, the color coding. And what do we see is 2015, 2016 was the strongest El Niño, okay? And as you can see, it lasted, about a year and a half, 20 months from November to June, with a maximum ONI index of 2.8 degrees. So this is all good. This is what happened in the past. So now we understand what is El Niño. I want to move into part 2, which is dealing right now, because this is what you and me are interested in. So let's look at 2026. So this is all the El Niño since 2020 with the ONI index. So pretty quickly, we can see that we had a strong El Niño, a very strong El Niño in 2023 to 2024 with a maximum of 2.1 degrees. It was actually not a major event. And then since 2024, we have been more or less for the past 2 years in a neutral phase, equilibrium. We had a very weak La Niña here, but so weak that it was not even referred as La Niña. And now what is happening in May 2026? There is a sign in the ONI index. There is a signal. We have reached 0.5 degrees, and this is why the scientific community is more or less raising the alarm that El Niño is coming. So right now, the June is not available, but it will be very soon. But this ONI index, for example, can also be measured weekly. It's less robust, but it's a good indication. And for example, on June 17, it was already 1.7 degrees, and of course, a plus. So there is warming, and we are expecting to see this ONI index increasing. I will be checking this value, and we will also give you the URL. Actually, it's right here. So you guys can go by yourself to track how the El Niño evolves. It's why the scientific community also is pretty certain that El Niño is coming. It's possible to use forecasting to see the ONI index. So this is it. We are right here in June 2026, and you can really see the ONI index, which is building and even going above plus 2 degrees in December. So this type, this is the name of the forecast model. It's not a regular forecast model. This is a seasonal climate forecast that predict conditions like months ahead. But as you can see, there is a peak around December, probably Christmas. And as you can see, 63% of the model runs are above 2.0 degree. This is why there is at the moment a 63% chance of very strong El Nino. So it's not a guarantee. That's why media will tend to be, oh, it's a certainty. There is a high probability that El Nino is coming. But now you know the numbers and you know the facts. Also, why people are getting worried. This is the SST anomaly. This is on June 27, so few days ago. This is real measurements. And here again, you can clearly see there is a warming, plus 4-5 degrees warmer than usual along Peru. So this is a clear El Nino sign. So high probability is coming and a 60% chance super El Nino. So now that we understand what are we getting with El Nino, which is coming, maybe a question you may have is, what's the big deal? Plus 0.5 degree, plus 2 degrees in the Pacific Ocean. Why does it have such a big impact? So the Pacific Ocean is the biggest ocean in the world, and this will have a dramatic event, especially for Asia, America, but also an impact all around the world. So I'm going to try to limit this part to just one slide. So this map, represents El Nino. This is what we saw before, with the UK Met Office drawing. So we've got the warm water in the Central Pacific creating all the convection. So what is happening in terms of the global weather over Asia? So over Asia, as you can see, we do not have convection, but instead we have more or less the air sinking. And the consequence is to have a clear sky, warmer air temperature, and also little rain. So countries in Southeast Asia like Indonesia, Philippines, Malaysia, they are facing, especially for the December, January, February, a weather which is going to be hotter than usual. So heat wave is going to be drier than usual, drought and fire, and also impact on drinking water, food supply, agriculture, etc. So this is really a big thing. Those part of the world are used to monsoon, heavy rain, and they will have a drastic change of the weather. And this will also affect India. So billions of people impacted and really dire situation. I know a lot of people are watching from Australia, and Australia, also especially in Eastern Australia, will also, with a high probability, be impacted by hotter and drier weather. Something I want to point out is during El Nino, as we said, about around 12 months, there will still be, some rain, but in average, it will be drier and hotter than usual. And what is happening on the America side? So places like Peru, Ecuador, this is the exact opposite. They're going to have more rain, but not a little bit. It's going to be much wetter and a lot of flooding. And here again, millions of people will be impacted. El Nino is in fact a very complex subject. This drawing is a real simplification. And when you really drill into it, if you look at Eastern America, actually this is like Asia. It's going to be hotter and drier than usual. So once again, take this drawing with a bit of salt. El Nino is complex. And to show you also the complexity, I actually want to show a second slide for this part, and it will be the last one. This is just looking, at Australia. And those are two El Nino events. So on the left-hand side, the 2002 one, as you can see, it was much drier than usual, almost everywhere. But, Tasmania was a bit wetter than usual. So once again, El Nino, what you're going to experience exactly where you live might be a bit different. But El Nino is a large-scale phenomenon, and we are looking at the large scale. But another phenomenon in 2015, another El Nino, didn't have such a big contrast. Once again, not all El Nino have the same amplitude. They do not affect the exact same regions all the time. But this is not a reason, to say El Nino is wrong. This is Mother Nature, and it's very important to look at the large scale impact on the global weather to really understand El Nino and its consequences. So now we covered the global weather, and we are coming into the final part, which is the impact for El Nino for sailors. So before, going into the Pacific, I want to highlight some key concepts regarding El Nino impact for sailors, okay? El Nino disrupts the weather and the wind around the globe, but it's like the rain, in Australia. We cannot tell you exactly how the wind is going to be on a specific day during El Nino. It's more in average. What are the highest probability wind conditions you're going to get during this period of 19 to 18 months? So important to remember this. So the winds will be disrupted, but we don't know the specifics. For example, we know that the trade winds are going to be weaker during El Nino, but they may still be strong and reliable if you do your passage the first week of December 2026. Just a random example. And this is why we believe that checking the weather forecast is very important during El Nino. As you know, the forecast is updated multiple times a day using initial conditions that actually capture El Nino. The SSTs are in the weather model for each run. And this is why the weather forecast will be the best way for you to really apprehend the weather and find a good weather window for you after passage. And PredictWind, we have some great tools to help you with this, such as departure planning to help you pick the best weather window, and also weather routing. So now that this is covered, let's jump into the Pacific. So this is the same drawing I showed before, zoomed over the Pacific Ocean. You recognize the big advection in the central Pacific. So if you are crossing from Panama to Asia, what are you going to experience? So just looking at the wind, as you can see here, El Nino is fighting against the trade winds. So the consequence is, in average, you're going to have weaker trade winds. So offshore passage have a high chance to become slower. The trade winds also are probably to be inconsistent. And even in some cases, they could be reversed temporarily, especially in the western part of the Pacific. In terms of instability, rain, convection, what we see is there's going to be more convection in average in the middle of the Pacific, like French Polynesia and especially Hawaii. And the consequence is storm formation shift eastwards toward the central Pacific. So you're going to have more thunderstorms, probably squalls, with wind shift, gusts, reduced visibility, which will make passage more challenging. So slower and more challenging. Also, typically during El Nino, we've seen that there are more hurricanes in the central Pacific, like Hawaii and French Polynesia. So once again, the sailing the Pacific is going to be more challenging, but you will still find some good weather window, but they will be just maybe shorter, and it will be more important to check the weather forecast. For example, I've got a colleague, Smiley, which is every year sailing from New Zealand to Fiji, is very used to the trade winds, and he checked the forecast always for every crossing. But during the El Nino, he will pay even more attention because he knows that all his experience is actually not really helping, because El Nino is the change in the regular normal weather that you always experience during the equilibrium phase. What I want also to point out is, because you are in the Pacific, you are close to this heat source of the warm SST, so the impact is going to be strong. It's almost like an earthquake. If you are close to the source of the earthquake, the stronger the impact. Now let's move further away and go into the Atlantic. As you can hear, as you can probably believe, we are further away, so the impact is going to be moderate. So El Nino has less impacts on the winds just because we are further away. But still, it has been noticed that the trade winds are going to be slightly weaker. They're also going to be slightly more variable, less consistent. And also in the North Hemisphere, the trade winds may shift southward a bit. In terms of convection, it has been noted that the hurricane season in the Caribbean tend to be less active during the El Nino years. As you can see, this downflow doesn't help the formation of hurricane. So this is a good sign for sailors, is the hurricane season should be less in the Caribbean. So expect a moderate impact in the Atlantic Ocean. An important note is El Nino disrupts the global weather and has indirect impact on major patterns. And it's quite difficult to really know the link between the two. And now I want to briefly talk about the North Atlantic Oscillation and the impact of El Nino on the North Atlantic Oscillation. So what is the North Atlantic Oscillation, referred as NAO? This is the difference in air pressure between the Iceland low pressure system and the Azore high pressure system. NAO negative means the pressure difference is small. So here is Azore high during a negative NIO. The high pressure over the Azore is weak, and the low pressure over Iceland is also weak, making a weak pressure gradient. And there is an indirect connection between ENSO and NAO negative. So here again, not a direct link, but indirect. So during this El Nino, there is a good probability to have more chances to have this phenomenon of NAO negative. And what is the impact of NAO negative for sailors? Okay. So here also I want to point out, NAO is always happening. It always changing. There is some positive, negative all the time, even without El Nino. But when El Nino happens, it tends to be more chances to have NAO negative. So what is the impact of NAO negative for sailors? Sailors crossing the Atlantic in the tropics or returning from the US to Europe at mid-latitude. So for the wind, having this weak pressure gradient between Iceland and the Azore make weak trade winds. The weak trade winds is due to the weak Azore high. Also, it tends to make weak westerly in the North Atlantic for a returning transat for the US. In terms of convections, what we find is an increased likelihood of winter low pressure system affecting the routes between North America and Europe. So the storm track shift further south. Usually it's further north, hitting the UK and Northern Europe. Having this weak NAO or NAO negative is just pushing those storms further south, impacting more the sailing condition. So now that we are finished with the Atlantic, I want to have one final slide to discuss the Med. So for the wind, as you can see, my little boat is not even on the map. So the Med is even more remote to the Pacific Ocean. So there is no real impact on the local winds because of El Nino. What about the convection and all this? This is where El Nino gets complicated, okay? El Nino is affecting the entire world. And something would be noticed is El Nino is associated globally with different heat distribution around the world, even in Europe. And some hot regions can become even hotter because of El Nino. So as you see, the Med is already a warm sea during the summer, and El Nino could contribute to increase SST. And if there is an increase of SST, the Med will have more energy for stronger events, such as Medican, that happens at the end of the summer. So as you can see, El Nino is just started. It's going to be with us for 9 to 18 months. So expect impact in the Med on the other side of the world, for example, for the summer 2027. And the impact is weak and indirect impact. I hope this webinar was useful. I want to thank you, everybody, for listening to this one. It was my pleasure to present this to you. Thank you.